So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass coder this side. So today the problem is strictly increasing array, and it is a very interesting problem, and as you can see it is also asked by Microsoft. Okay, the problem is really easy, right? You will be understanding it in a bit. Okay, so the problem says that you have been given an array given as 1 2 3 6 5 4. Okay, now you have to make it a strictly increasing array as mentioned here, right? Strictly increasing. What do I mean by strictly increasing? I mean by strictly increasing that for every pair of I, j, where I is greater than j, array of I should be greater than j. Remember, I'm not using an equals to sign. Okay, it should be greater than j. It should be greater than array of j. Okay. Now you have to determine number of operations, or I can say minimum number of operations to make this possible in the given array, right? Okay, now one operation is defined as you choose an index ith index, right, and change it and increment it or decrement it. That is your option, right? Or decrement it. Like you have to determine how many elements would you have to change, how many minimum elements you would have to change so as to make the array as what do we say, strictly increasing, right? Okay, so in the question given, if I change 1 2 3 6 5 4 to 1 2 3, after that 6 can be changed to 4 and 5 can be remain same, so I change this and 4 can be remain to 6. So I change these two values, and henceforth my answer is 2 for this case, right? This is the minimum possible case I can have formed. I could have also gone for 6, then this could have changed to 8, and this could have changed to something 9, okay? And that would also be a valid approach. So there can be many possible answers for the array, but we don't have to answer for the exact array. We have to give the answer for minimum number of operations, right? So we have to give us the minimum number of operations, like these operations. So that is 2 in this case. Okay, so I hope you are clear with the input and output scheme of the question. Now, how do you approach it? How do you approach it? One approach is you start from here. Okay, 1, you encounter 1, you see 2, change it. You see 2, 2 is greater than 1, nothing happens. 3, nothing happens. 6, nothing happens. 5, change it. Okay, so 1 operation here. 4, change it. That's 2 operations are 2. But it will fail for most of the complicated cases, right? Most of the complicated cases. See, I was not able to look out for the brute force approach, but I tried to figure out that how will this code work. Okay, so our example is 1 2 3 6 5 4, and I have to make it strictly increasing. I explored the question and I tried to find strictly increasing case of LIS. Strictly increasing case of LIS. What do I mean by LIS? LIS is longest increasing subsequence. Longest increasing subsequence. This is a famous DP problem, and if you have solved it, congratulations, you have 90% done with the question, right? So longest increasing subsequence is a problem that gives us the length of the possible longest substring which is increasing in nature in the given array. For example, if I try to take out the possible subsequences, number of possible subsequences are, I can only take one, I can take 1 2, I can take 1 2 3, 1 2 3 6 5 4, right, etc etc. But the longest increasing subsequences are that for subsequences such as 1 2 3 6, it is the longest increasing. 1 2 3 4, it is also longest increasing. But 1 2 3 6 5, it is a subsequence, but it is not longest increasing, right? So we will have to find the length of the longest increasing subsequence. So in this case, one valid example of the longest increasing subsequence is 1 2 3 6, right? Let us take this longest increasing subsequence for now. Okay, if I took this, can I say the length of the longest increasing subsequence I found is 4. Length of this is 6. Okay, length of this is 6. What should be my answer now? What should be my answer? My answer should be 6 minus 4. How do I come to this conclusion? I will say that these elements are already strictly increasing subsequence, right? These are already increasing in nature. I just have to change the remaining elements, that is these two elements, to make them increasing. I have to change only these two elements to make them increasing. Okay, that is my approach. So my approach is I will find length of longest increasing subsequence, right? This is my first step. Second step, answer return n minus length, right? So what I'm doing is I'm finding the length of longest increasing subsequence and return n minus length. That is the approach clear to you. That is the approach clear to you. Now you just have to understand longest increasing subsequence, right? Longest increasing subsequence. There is a slight differentiation in the implementation of the longest increasing subsequence. We will discuss it further when we go to the video, and then we will be solving it. Okay, so longest increasing subsequence, let me name it as LIS. How will the code for LIS work? Okay, so LIS is actually a DP problem. So the flow says that I have to tell you about the recursion first, then I will tell you about the memoization, then I will tell you about the tabulation, right? But because of shortage of time, and LIS is a pretty big famous problem, so I will just tell you how the tabulation scheme works. That is also very easy to understand, right? So the tabulation scheme works like I have 1, 2, 3, 6, 5, 4. This is my array, right? I will make another array and DP array, of course. Okay. Now DP array, here DPI is length of longest increasing subsequence ending at I. Okay, ending at index I. DPI means length of longest increasing subsequence ending at index I. Now you tell me, for all these elements, can the minimum length be 1 or it will be 0? I have two options for you. It is 1 or 0. What is the minimum length? Okay. So you will say that for each and every element, this is a valid subsequence, right? This is again a valid subsequence. This is again a valid subsequence. Right? 6 is only 6 is a valid subsequence, right? So I can say that each element on its own is a valid subsequence. So the minimum value of every index at DP is 1. Okay, so we cut that DPI is minimum 1 for every element. Okay, I start from this. Okay, I start from this. This is my I right now. I will take another loop J, which will go from 0 to I. Which will go from 0 to I minus 1. Okay, 0 to I minus 1. In this case, J will not be working because I minus 1 is already minus 1. Okay, I move my I here. My J will now move to 0. It will see if this, oh sorry, if now J will be here now. If J is greater than is less than I, yes, 1 is less than 2. So this is a valid LIS, right? This is a valid LIS. What is the length of the LIS up till 2? It will be 1, this 1 plus 1, right? That will be 1, 2. This 1 plus 1. So it will be changed to 2. Now for 3. First my J is at 1. Is it a valid subsequence? Is 1, 3 a valid subsequence? Yes, 1, 3 is a valid subsequence. So it will be 1 plus 1, 2. My J comes here. It says, is 1, 2, 3 a valid subsequence? Yes, 1, 2, 3 is valid subsequence. So my answer will be 2 plus 1. This 2 plus 1, that is 3. Okay. I move to 6. I see that J here is 1, 6 a valid subsequence? Yes. The potential case is 2. Is 2, 6, is 1 to 6 a valid subsequence? Yes. So 1 to 6, 3. Is 1 to 3, 6 is a valid subsequence? Yes. So 4. 6 will store 4. Moving to 5. 5 will say, is 1, 5 a valid subsequence? Yes. Is 2, 5, 1 to 5 is a valid subsequence? Yes. Is 3, 5, 1 to 3, 5 is a valid subsequence? So it will be 3 here. Yes. Is 1 to 3, 6, 5 a valid subsequence? No. So it will remain 4. Going to 4, going to 4, it will say, is 1, 2, 3, is 1, 4 valid subsequence? Yes. What about 1 to 4? Yes. What about 1, 3, 1, 2, 3, 4? Yes. 1, 2, 3, 6, 4? No. 1, 2, 3, 5, 4? No. So it will remain 4. So my TP array is 1, 2, 3, 4, 4, 4. This is my DP array. And you can absolutely see that the longest increasing subsequence is of length 4. I can take either this one, I can take either this one, I can take either this one. And my answer will be, my total length is 6. My longest increasing subsequence length is 4. So my answer is 2. My answer is 2. Okay. Let us try out a different case. A case where this situation will fail, right? Because it is very interesting to see the cases where the current situation fails. Okay. So if I take out 10, 5, 5, 2, 4, 10, 3, 2, 7, 9. This is my array. This is my array. Let us take out the DP array for it. Let us take out the DP array for it. All of them are changed to 1 first. My I goes here, nothing happens. My I goes here now. It will check for all the values defined. Is 10 less than 5? No. That is the only case. My I comes here. Is 10 or 5 less than 5? No. My I comes here. Is any element less than 2? No. My I comes here. Is any element less than 2? Yes, 2 is less than 2. So my answer will be maximum of 1 plus 1, this 1 plus 1 or 1. That will be 2. It will change to 2. I come here at 10. I see, is there any value less than 10? Yes, 5 is less than 10. So this is the potential subcase, this is the potential subcase, this is the potential subcase, this is the potential subcase. Now I will get the maximum length if I add 2 plus 1 other than 1 plus 1, right? So it will change to 3. I move to this, any element present which is less than 3? Yes, this is present. 2, that is already 1, so 1 plus 1 it will be 2. I come to this case, no element is present which is less than 2. It will remain 1 only. Goes to 7. Any element present is less than 7? Yes, this element is a potential subcase, this is a potential subcase, this, and this, and this. What is the maximum among all of these? This is 2. So 2 plus 1, 3. Okay. I went to 9. I went to 9 and I saw, is 9, what is the maximum? So you can see 7, 2, 3, 4, 2, 5, 5. All of these are possible, but 7 will return me 4. 7 will return me 4. So you will say that the maximum length here is 4. And what is the total input length? So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10. So 10 minus 4 is 6. So you will say 6 is the correct answer, right? You will say 6 is the correct answer. Okay, you are accurate up till the amount, but what is the subsequence we chose? What is the subsequence we chose? We chose 9 paired up with 7. 7 paired up with, we chose 4, right? We chose 4, or we chose 3. We chose 3, sorry. So 3. And then 7 paired up with 3. 3 paired up with 2. And this was a subsequence of length 4. This was a pair subsequence of length 4. So our subsequence is 9, 7, 3, 2. This is a subsequence, right? This is a subsequence. Now, if you observe 7, this subsequence is correct, right? 9 minus 7 is 2. Okay. 7 minus 3 is 4. 3 minus 2 is 1. Right. So these are the cases, right? Why do I have calculated the differences? Why have I calculated differences? This difference here is how many elements are present between this interval. This is first element, this is second element, this is third element, this is fourth element, right? To make this array strictly increasing, should I have to find 2? This element should have been at least, this element should have been at least 2 plus 3, that is 5. Why do I say it? Why do I say it? I say it because if I want to make this particular array longest increasing subsequence, this particular array, I'm not talking about these 2 points, I'm saying this particular 2 arrays, what do I have to do? If this is is greater than 5, only then there will be possible values for these two to make them increasing. See, what was our concept? We are choosing the LIS, right? We are choosing the LIS, but our initial concept is to make this array strictly increasing, right? Make this array strictly increasing. So if I choose 2 here as a particular, that this is set, right? I don't have to alter it. If I choose 3 here as this is set, this is not alternating. Is there any way to choose values for these two? Is there any way to, if I have an element 2, 3, I say these are compulsory. These two elements are not changing and I have to insert 2 elements between these. which should, and this array should be forming strictly increasing. Is this even possible? Is this even possible? You tell me. I don't think this is possible. Why do I say it? If 2 is here, 3 is here, is there are no values. There are no values I can fit into these two values to make this array strictly increasing. So I will have to add a condition that whenever I'm updating these values of dp, array of I minus array of j should be greater than equals to I minus j. Where does I minus j comes from? Suppose this is 0, 1, 2, 3, right? 3 minus 0 is 3. So, okay. So 2, it can come 3 here, it can come 4 here, it can come 5 here. So 2 plus 3 is 5. This is the minimum subcase, right? 5 can be minimum present here. 5 is minimum that can be present here. So that only then I will be able to insert 3 and 4, right? Only then I will be able to insert 3 and 4. So 2 plus 3 is 5. So this condition should also follow before changing this value. Before changing this value. This was the only modification I have to made in the LIS. Okay, so our code now becomes, our steps becomes calculate max length LIS with slight modification. We just introduce with slight modification, right? A second step is return n minus l, where l is the length observed from maximum length LIS. Now let us write the code for LIS, right? Our code for LIS. So LIS will take my array A, which is given to me as input, right? I will make a DP array. I will make a DP array of size n, where n is the length of array, and declare all of them as 1, right? Okay. After that, I will start my loop. Like you can start from 0, you can start from 1 also, because 0 doesn't have any subcase. So I will start from 1 only. 1 to n minus 1. What will I do? I will say for j, going from 0 till I minus 1, that is the element just before ith element, if uh, array of I is less than array of, is greater than array of j. This is my first condition, right? And array of I minus array of j is greater than equals to I minus j. This is my second condition. What do I have to do? I will change my dp of I to maximum of already dp of I, which is already existing, comma 1 plus dp of j. Okay, so this is the subcase, this is nested loop. Now after this, I will return the maximum possible. So I will make a maxi which is equals to 0. I will traverse. So for auto iterator in dp, maxi equals to max of maxi comma 8. Okay, so in the driver function, I will say my L is LIS of array, right? And I will return n minus n. This is my whole pseudocode. This is my whole pseudocode. We have discussed the dryer and we have discussed the flow chart. We have discussed everything. What is the time complexity now? What is time complexity? So if I come to the code, I will be able to see that I am using a concept of nested loop. One loop is running n times, the second loop is running I times. So in this case, the complexity is n square. So O of n square is the time complexity. What about the space complexity? So I'm using an dp of n, that is of n space complexity, right? So I think the pictures have been made clear to you, right? And it's time for the beautiful thing which is known as code. So I will come to the coding section. In the meantime, if you have not subscribed to my channel, I would request you to subscribe to my channel. Plus, I would request you to connect me on LinkedIn, connect with me on Instagram and other social media platforms, right? The links are provided in the description. Make sure to follow me. And okay, so let us do this. So what do? We are saying that intel equals to lis, and I will send my nums here. Okay, my int10 is equals to nums dot size, that is total input length, and return n minus n. Okay. Now coming to the lis formula. So int lis, taking it vector int. I'm changing the name of nums to array for my convenience, right? Int n equals to array dot size. I will make a dp vector, so vector int and vector int dp of size and initialize all of them by 1. Now, for int I going from 1, I less than n, I plus plus, right? For int j going from 0 up till I, j plus plus, what do we do? If ARR of I is greater than ARR of j and ARR of I minus array of j is greater than equals to I minus j. We discussed why. What do we do? dp of I is equals to max of dp of I comma 1 plus dp of j. Right? At last, my int maxi equals to 0 for auto it in dp. Maxi will be getting updated. Return maxi. Right? This should work fine, right? So let us try to run it. Um, okay, so it is running fine for compile and run. Let's try and submit it. In the meantime, if you're new here, do not forget to subscribe. And you can see we have successfully passed and it has been a 112 days streak. Thank you guys for watching the video and we'll meet tomorrow with a new question and a new practice, right? Thank you. Have a nice day.